Welcome to a special edition of Raising the Bar, focused on teaching remote labs in physical sciences and engineering, with special attention to lessons learned from spring 2020. This one-hour webinar features Dr. Heather Lewandowski, Professor and Associate Chair in the Department of Physics at the University of Colorado at Boulder, and Fellow of JILA, the prestigious Interdisciplinary Research Institute. I'm Steve Dandino, Associate Provost at Colorado State University and Director of the Reinvention Collaborative. And on behalf of the RC's Research University members, I thank Dr. Lewandowski for her participation, as well as Dr. Kristan Corwin, Division Chief in Applied Physics at the National Institute of Standards and Technology, or NIST, for helping to organize this session and for moderating. Dr. Corwin, the floor is yours.
Thank you very much, Steve. It's a pleasure to be here. Before joining NIST, I was an associate professor, full professor, associate dean in physics, and have worked with many people on the screen here, and it's great to see these friendly faces again. Heather Lewandowski and I were in graduate school together at the University of Colorado, where she is, as Steve said, associate chair and professor of physics and a JILA fellow. She leads two research programs, one in experimental molecular physics and the other in physics education research. Her molecular physics research focuses on studying interactions and reactions of cold, chemically important molecules and ions. Her physics education research program studies ways to increase students' proficiency in scientific practices, such as using models and quantitative reasoning in experimental physics. Recently, she and her colleagues have posted a paper on the archive entitled Teaching Labs During a Pandemic, Lessons from Spring 2020 and an Outlook for the Future, from which I am sure she will draw for today's presentation and discussion. I'm delighted to welcome her as our speaker. We have plenty of time for questions following her presentation. You've all been raised to panelists, so please mute your mic. I see you all have. And if you wish to ask a question, raise a hand and I will call on you, a real hand, unless you don't want to show video, in which case put it in the chat. Or if there is a pause, you can try to speak. It's just we've all been in these webinars where everyone tries to speak at the same time. So I will try to help direct traffic. That's my primary role. All right, with that, I turn it over to Heather Lewandowski. Welcome, Heather.
Great, thank Kristan and Steve. So today I'd just like to give you just an overview, some of the basic ideas that we had sort of gained from a study that we conducted looking at physics lab instructors and students during the switch to emergency remote teaching in the spring. And then most of this time will really be hopefully questions to talk through different ideas as we all approach the fall with some uncertainty, but I think that there is a lot of hope there. So let me just share my screen presentation here. Great. So this work was done by three postdocs working in my physics education research group, Michael Fox, Alex Worth, and Jessica Hain. And so just to give you a sort of an overview of what the goals of this project were, and hopefully why we embarked on this, was really sort of to document sort of a variety of hopefully creative approaches and strategies that the instructors took during this time when they had to rapidly switch from traditional in-person labs to remote teaching. And ultimately determine the impact of this transition on students' views of experimental physics, their ideas of the nature of science and what experimental physics is. And so this was sort of the overall goals of the project, ultimately looking to the future of what we could learn from this when we do come back in person. And so to do this, we collected a lot of data in the spring. We were fortunate enough to be running a survey already with a lot of students. And so we were able to add extra questions to a survey that was already ongoing. And so we have responses from students, from about 2,200 students from about 50 courses, mostly throughout the US. So we have that as data to pull on, as well as instructors. We had a follow-up survey with instructors sent out broadly. We got very good participation with over 100 instructors sharing what they had done and what had worked well and not as well during the spring. And we've now then followed up with in-depth interviews to really get at some of the details of what happened in the spring and what people are thinking about going forward. So what I'll present today really comes from this data set. So first, just talking about instructor data, because I think both instructor and students should be equally valued in this enterprise. So first, thinking a little bit about, sort of motivations for what instructors did. So, one of the things we asked them was, when they were deciding, how to teach during this switch to remote instruction, what guided their approach? And I think very interestingly, that the number one thing was really met the course learning goals. And we'll come back to this idea of really deciding like what is important and what maybe we've been doing for a while, but maybe isn't all that important that students learn in this lab class, but has been traditionally done. And so I think that is one of the things that really sort of came across both in the interviews as well as in the survey. There are various other things. Notice here that had consensus from the department wasn't a very strong thing. And so this is going to be proof also interesting because we've found that some people who had wanted to do some interesting things really maybe weren't able to get everybody on board, but were able to try something new for the first time and actually worked surprisingly well. And hopefully are being able to carry that forward when they come back in person. So that was an exciting positive thing from all of this. So thinking about the fact that faculty really were focusing on learning goals. Taking a look at what happened before and after the transition gives us some insight into thinking about what we prioritize in the lab. So on the left-hand side, these are sort of the general ideas of learning goals before the transition to remote instruction. And then on the right-hand side is after. And so the Skanky plot shows the idea that there are three basic categories, whether you really want to develop lab skills, modeling, data analysis, things like that, or really to reinforce physics concepts, sort of think about conservation of momentum or electric field or things like that. And you can see that, there was a significant shift here from courses that basically tried to do both about equally. They really shifted to doing primarily physics concepts. And this is not all that surprising literature. A lot of remote classes really are focusing on the concepts, partly because that's what's sort of afforded in this remote environment. But a lot of folks didn't switch. So there was some switching towards concepts, but a lot sort of stayed in the same regime. Another thing to think about, and this is really important in remote work, is thinking about group versus individual work, right? Now you can't have students coming together and actually being in the same space, but we know that science is not an individualistic endeavor, right? It is a team and a community effort. And so this is a big concern, thinking about how we have students still be able to collaborate and really sort of notice that there was a large shift from before to after, from group work to individualistic work. And I think going forward, that maybe is something we really want to focus on, is how to foster collaboration in this remote environment through different technology. So I think that's one of the main takeaways we saw, that this did shift that way, but maybe we want to think about how we can maybe shift it back a little bit. And when we ask instructors also about the challenges, right? What were their biggest challenges when they did this emergency remote teaching? And their number one thing was providing students with a similar experience to in-person labs, right? So trying to replicate the exact experience they had when students were able to come in and work with equipment, work with each other. That was a real large challenge for our instructors. As well as, sort of time constraints, right? It was just a very stressful time. And so that was really sort of one of the main things. And so, because it was a real challenge to replicate that, that's where I'm going to sort of maybe push on a little bit of thinking about, do we want to replicate something in a completely different thing, or do we want to take the best affordances of this remote environment and try to actually have a good experience in that remote environment and not just try to duplicate? So those are some of the things that we got from the instructor day, and there's a lot more in a larger report that I'll put a link to at the end. but equally important, if not more, are really looking at student data and having the student responses and student voice to what they experienced in the spring. And so if we look at some of the challenges that students faced, right? So rank how how challenging the following aspects of your course were during the remote lab instruction, right? Number one was being able to do experiments with physical materials, right? That really went away for a lot of students. There were some creative things of sending kits to students and having things do remotely, but that was a real challenge for students. Second, we come back to this idea of, right, having a partner or group to help conduct experiments. This sort of collaborative nature also the students really noted. And in the open response, that is something they really missed, was collaborating with their classmates. Now there's this thing right at the end that says access technology. And you might say, oh, well, that isn't a challenge. I want to put a very large caveat on this, right? These survey responses were collected from an online survey. So those folks who did not have access to internet or reliable fast internet weren't able to actually report on this survey. So I caution you to take that with a grain of salt, that is a very biased sort of response because of the nature of the survey itself. So I just wanted to point that out. You know, when we took a look at sort of their views of remote labs and asked them sort of to compare the in-person labs versus the remote labs, you know, where were the remote labs better in their opinion, right? And so there are two things that really stick out that I think are very encouraging as we look forward. One is enabling me to work at my own pace and enabling me to control my own learning. It sounds as if the students were afforded more agency in these experiences, right? And they really enjoyed that aspect. So I think that's one of the things that we want to think about, not only for the fall and the spring, but maybe when we come back in person about, you know, how much opportunity we give the students to have a sense of agency over their learning and over their experiments. Of course, on the other end of things, you know, helping me to learn laboratory skills, and once again, more productive collaborations, right? This collaborative nature really gets lost when everybody is so remote. And I think there are places where we can learn, particularly maybe from high energy physics, where most of their collaborations and interactions are remote. And how do we get that from what they're doing and bring it into the classroom? So, you know, just to sort of wrap up some sort of takeaway messages that you might want to consider from these data as well as the larger report that we had. One thing is to reevaluate your learning goals, right? Maybe evaluate for the first time, right? What do you care most that your students learn? And I think this has been really exciting to see folks really think about, well, yes, I know we've been doing this for the last 20 years, but do I really care if they can do X or Y? Not really. I don't want them to miss out on this other thing. And so I think that in some way is one of the major takeaways, is to think about that. Don't just try to replicate what you had in person in the remote. Think about what you care about most. Another important thing is don't assume students have access to cell phones, household materials, fast, reliable internet connection, right? Think very carefully about this. A lot of folks said, oh, cell phone is a great sensor. Yes, but smartphones are not universal, and this can really disenfranchise students who don't have that technology. Even household materials. One instructor had them doing something with sticky tape, and I found out a lot of sort of undergraduate students don't have Scotch tape in their house, right? And so this alone was sort of a barrier for them to complete the lab. So think carefully about that. Another thing along this idea is, you know, think about what materials and technological tools to utilize in a remote class, right? Think about accessibility for folks with disabilities. Think about, is that simulation, does it have a screen reader option, right? Think about these different types of technologies and where they can actually help and also maybe inhibit students from fully participating in the class. One of the things that we found from the study was that sort of the flexibility provided by these open-ended projects, you know, if managed well, really was quite successful. And this comes up again about this idea of students sort of taking ownership of their own learning and having more sort of agency and decision-making in what they're doing. Another thing we saw from the open-ended responses that sort of synchronous short meetings with small lab groups really worked well to help build that collaborative nature of science, much more so than sort of larger groups, big, long, or meetings or any asynchronous communication. So having some synchronous component with small lab groups, I think is really important to consider. And, thinking big picture, this was and still is, right? It's a new situation for all. Things will go wrong. And I just want to stress that that's okay. So, a little flexibility and empathy in part of the instructors just goes a long way to having a positive outcome for all. So I would just think about that carefully when you're in the middle of a semester. Just think about these things, and, we will be back in person at some point, and we're just doing the best we can right now. So a lot of these ideas and a lot more on very specific ideas for labs in the context of physics, but I think very much translates over to other physical sciences and engineering, is located in the archive on a report that we have there. Great, that's all I have. Thanks.
Thank you very much, Heather. We actually have a question in the Q&A box from Kate Ross. Kate, would you like to ask this in person, or shall I just read it? Well, I will read it and she can elaborate if she wishes.
Sorry, can you hear me?
Go ahead, please.
Sorry, I was trying to figure out how to actually be unmuted.
Understood.
So, yeah, my question was about, so with the responses from the students, one of the biggest things that they rated as being challenging was being able to do, I think it was something like being able to do hands-on experiments with materials. And I was wondering, I mean, if I had that question asked to me, I'd be like, well, yeah, it's online, so it's really hard to do things. But I wouldn't necessarily connect that to that was a big detriment of the course. How do you interpret the responses to that question?
Right, so not only the closed form responses that I sort of presented here, we had a lot of open responses. Basically, students and instructor wrote quite a lot in these open text boxes, and we were seeing that they also did feel like they were missing out on that hands-on experience. The students really did sort of miss that experience. Not only was it challenging for them to engage, but they wish they had more of that. Hopefully that answers the question.
Yes, thank you.
Well, I don't see any hands raised, so I'm going to ask about the kits. I know that at CSU, they successfully used kits in the physics department, and or at least I believe so. And I see Ken nodding, thank you. I wondered if we could talk a little about what challenges you saw, Heather, and how CSU addressed them. That might be helpful for future listeners.
Yeah, I mean, I think it really depended on the student population and sort of the nature of the institution. We had one institution which was native serving, which really an instructor drove out the kits to the individual students, right? Because that was really the only way to be able to deliver these kits. There are various other forms of like packaging it up and shipping it to folks. I think it was really hard because of the time scale as well, because it was, sort of immediate. There was no planning really time. So I think that was probably extra challenging for that. I will say that going forward, there are a lot of challenges with international students who aren't able to come to the States. And so shipping things to them is proven to be a real challenge going forward. And people really haven't found a great way around certain items of how to ship that.
It's an interesting challenge. Okay, Martin Gelfand?
Yeah, just a quick question, Heather. Was this all, intro courses that you were serving, or were some of these upper division labs as well?
Actually, they're fully across from intro up through advanced. So there's quite a range of courses represented in this study.
Jake Roberts.
And then maybe as a follow-up, so did you see different trends between the upper level courses and the lower level courses
in terms of the responses and what the students said, general attitudes and things like that?
Yeah, so I think we haven't quite done that analysis yet. We sort of rapidly did a basic level analysis to get this report out. Hopefully folks can use it going forward. There's a blue jay out here, I apologize. It's rather loud. And so it would be interesting to see the difference, because in a lot of things we see a difference between intro physics, where there's a wide variety of majors versus more majors only classes. And so they have different views of things. So that's something we are looking at now. So I don't quite have the answer yet. But that's a really good question.
And maybe a different question, because one of the things that we've noticed was in the spring, there was a lot more of this move to individual, just kind of, out of necessity. I mean, it wasn't,
yep.
Something. And then we found that was a huge detriment to student performance, and also I think the student experience. So we're working on, over the summer with our courses, we made remote groups, and I think that's been successful, and we're thinking about this for the fall. I guess my question is sort of what was the breakdown maybe in the survey between people who were able to maintain the groups and people who weren't, and then whether or not our experience, it sounds like from what you said this is really typical, but maybe just to hear a little bit more on the range of responses. Are we right smack dab in the middle of what people experienced, or was some people actually appreciated the individual effort? Just to talk a little bit more about that.
Right. So let me just bringing up I realize you can't see this, but the numbers, so I have them in front of me. So before the transition, folks reported that 82% they had group work only. So students always worked in a group. And that cut down to only about 25% afterwards. So it really shifted quite dramatically to individual work, which is natural in this environment, because everybody is physically distant. So I think regardless of that shift that in some ways, like you say, was natural and sort of had to happen during the spring, how can we go forward in the fall and likely spring of 2021 to sort of bring back that group nature, right, of that work? I think that is a challenge for us. One thing is to think about the relative ratio of synchronous versus asynchronous. So at the University of Colorado for our intro lab course, we're completely changing that, and it's all group work and thinking more about, producing, individual sort of artifacts as a group and having that supported by the TAs in a synchronous lab environment. Because I think the challenge also in the spring was everybody was in very different time zones. And so group work was even harder. That will still be a little bit the case in the fall, but I think not as dramatic. And so we can also build groups in different time zones and thinking about how, so they can easily collaborate synchronously.
I wonder if a little bit of the shift away from group work is an advantage. It seems that lab instructors were sometimes frustrated that they could only get group work. Students were frustrated that a grade might be reflective of the entire group and not their own performance. So I wonder if there's some advantage here. Obviously, 100% individual work is not most likely ideal, but maybe we don't want to go all the way back to 100% group.
So this is an interesting point, and I'm pulling on from other studies now from the National Photonics Initiative and the National Quantum Initiative, with two separate workforce studies. And one of the number one things that folks wanted for incoming employees is the ability to work on interdisciplinary teams. And so I agree, there is a lot of frustration sometimes from students about group work of being evaluated. And I think part of this is how we evaluate. We still evaluate as an individual and value only individual work versus valuing the group work and how the group works together. And I choose to bring up a sort of creative strategy that Danny Caballero at Michigan State uses to think about this tension between group and individual work, where they their groups do have some individual assignments and some group assignments. And at the end, the students get to weight those various things according to how they feel they should be weighted. So if they feel that really, their group was not as functional and they really felt that their work individually should be weighted higher, they can weight that a little bit higher. So that gives them also, some opportunity to have some agency over their evaluation too. So I think I agree there is some tension, but I think there's some creative ideas out there to really still value group work, because I think, in science and engineering and industry and academia, it's just so critical that we want to continue to keep that collaborative atmosphere.
Yes, a question from Heather, a different Heather.
Asking about groups, one of the things I get to teach astronomy labs, and one of the things I struggle with, how do you make a group without meeting the people? How do you spice it up? But also, I worry about siloing women alone in a group, and then having to navigate that piece of things. Did your research find anything? Is there a good way to do stuff like that?
Yeah, so I definitely pull on some external research for this. One of the things that they have found is actually single gendered groups of women actually are very productive and work very well. So, and I can point you to some papers. So that is not necessarily a bad thing. What we're doing for our courses in the fall is we're sending out a survey to get to know folks a little bit. So we're going to have using Google Colab as a Python environment for our introductory physics course, which is brand new. And we're going to have a very strong group work component. And so we're going to ask them, their programming experience, how comfortable they are with working in groups, and use a lot of that kind of information to very deliberately form groups. And so I agree, you do need to get some information to make sure that you're forming groups in a good way, but also single gender groups have been shown to perform very well.
Heather, again, please.
On a question kind of about your talk, you talked about the students really liked the self-paced nature and being able to kind of explore things in their own way. Were those labs built on more open-ended questions, or how were those labs structured?
Right, and I think one particularly successful example was an institution that it was a sort of a senior level lab that was very prescriptive. It was sort of a traditional sort of modern physics lab where is very, step by step. And because of that, they really couldn't work with equipment. So they really completely changed that course. This was also an instructor who wasn't sort of allowed to change the course previously because, you must do it in this exact way. And so they really switched to this more open-ended inquiry and sort of research question generation during this process. And so in this particular example, the students would actually develop a research plan and how to take data. They would submit that as a job to the instructor and TA, and they would go in and follow and take the data. They would get the data to the students. So, in some ways, there's not one answer to any of these questions. The number of creative solutions people came up with equals about the number of instructors.
I don't know if I would have the discipline to follow those rules exactly when I knew a better way myself as an advanced lab instructor. Was that more for upper level labs, Heather, or did it also get used in the intro labs?
There were various sort of instances of that. I think of an intro lab where basically live streaming, the students would direct the instructor or the TA, okay, now go over there and do that. So one student remarked like, oh, this must be what it's, I have this giant list of things to do and I tell somebody the data to take and then I get all the data. That must be what like being a PI is like. And so they had this really different experience. And so, look, this was a horrible experience in general, but there are some silver linings to this that I think we really want to hang on to and think about when we move back to in-person. And that's one example of students being able to develop their own research questions and their own procedures, right? They really have those capabilities, and let's make sure that we give them the opportunity to try that out. I think Kate had her hand raised.
Yes, thanks. I was going to jump in. I was wondering about the use of simulations to try to replace some of the hands-on activities. What findings did you come across there?
Yeah, I think the main sort of replacement for hands-on in terms of simulations were PhET simulations, also developed at the University of Colorado. And so a lot of folks use those. There's also something called Pivot Interactives, which is essentially a bunch of individual videos taken where students can go through and actually take like measurement tools on the screen and do actual measurements using the data of the videos. And so there were various sort of instances of using those types of simulations. In some ways, that sometimes was the easiest to sort of replicate the in-person experience, in particular for the introductory courses, using these types of simulations. And they're very user-friendly, and so that went generally pretty smoothly for folks.
Mm-hmm. Thanks.
Heather, another strategy you talked about in your paper was having instructors send out data from previous years to students to analyze. How widespread was that? And I assume we don't need to get permission from the former students to send out that data, but maybe we do. I just wondered if you could talk a little more about some of the issues around that.
Yeah, so some instructors, and I think we found this more prevalent in the upper division labs than the sort of introductory labs, where data was taken maybe on a Mu on Lifetime experiment previously, and they were able then to send that data out. And there the goals really focused on the data analysis component of that. One caveat to using this is students said in a lot of their open-ended responses that often they were sort of given the data without the context of how the data were taken or the apparatus, and then it was much harder for them to understand how to do the analysis or what really the research question was. And so making sure students understand, you know, how the data was taken, under what conditions, and what the data actually means from that apparatus instead of like time and voltage, right? And there you go. I think that's one thing that we want to think about when we do give students old data, whether it's taken that semester by the instructor or taken by previous students.
Deborah, please.
You're on mute.
I tried to unmute. Deborah, please. Oh, Deborah, you're on mute.
Sorry, I thought you were going to unmute me. I guess I'm wondering a lot about maybe, is there some certain amount of success that was observed in sending out kits or having students use household materials? I guess I myself am kind of particularly fond of the hands-on kind of household material types of things. And I'm wondering what students' reactions were to that. And I'm even wondering, you know, if the student themselves don't have these certain types of materials, maybe we can turn that into more of like a design type of procedure where they do work with the group. But, you know, mostly I'm just interested in, you know, what were students' feelings of these kits, because that still actually got something physical in their hands. And I just think that's super important. And maybe I love the conceptual classes to drive home those points. So I was just wondering if there were any trends observed.
Yeah, so two responses. One, in terms of what they have at home. One instructor actually did a quick survey and had a whole bunch of different types of materials and said, what do you have at home? And so that I thought was really a great idea. And then sort of built like, okay, you can work, you know, we'll have work on these kinds of labs because you have that material. Like, we don't want you leaving your house to go get materials, particularly then, and you can have this. And so instructors chose, actually set a select set of these things that students could choose from. once again, having more choice in that. In terms of, household, I think that did work really well for some groups that had very simple types of apparatus, where it's like, find a can and roll it down a incline, right? Almost everybody has some sort of can of tuna or something laying around that you can use, and some sort of flat board or a book or something, and either a stopwatch or a phone or some sort of timing device. And so I think that there was pretty good success with a lot of those types of labs. And of course, this is really focused more on the introductory labs, right? It's hard to build a second generation laser out of household materials, but sort of simple pendulum and things like that really can be done at home. And we really want to look at the data, looking at sort of the nature of science, of how they view, sort of how much it's connected to the real world some of the physics is. We haven't done those analysis yet, but I think it's going to be interesting.
Another thing mentioned was pinhole cameras to view the sun. I'm wondering how much interest that holds when there's no eclipse going on. Can they see anything, or is it just a ball?
Yeah, if sometimes you can get sunspots and things like that if you're near solar max or things like that.
Heather, could you comment on extending these results to other disciplines, chemistry, engineering? I know you've had conversations with your colleagues at CU about that.
Yeah, I think, the hands-on nature and the sort of level that is sort of required to do a lot of experimental physics is probably very similar to engineering. I think there are some differences to chemistry. I'm quite embedded within the chemistry community as well. And there's a lot more sort of lab skills, very, very prescriptive, very needed types of lab skills, like I need to be able to do this type of titration or something like that. That's a little bit harder than some of the physics labs to really pull out of chemistry. And I think going forward, we're seeing a lot more of hybrid type labs where students are rotating through to really still get some of those hands-on types of experiences where you can't ship kits, right? Because a lot of the chemicals just aren't safe to be able to ship. So I think there are some differences. I think more the global types of things of thinking about collaboration and group work, thinking what we can do in a remote environment, because there are things, there's thinking of modeling, both computational modeling of systems, thinking about communication, which is also a part of experimental science, like how are we communicating our results, reading scientific papers, how do you get something out of a scientific paper, right? There's a lot of skills that are sort of contained within experimental physics you don't need to do in the lab. And so we are missing the hands-on component, and that is a shame for most labs, but let's see what we can do really well in this remote environment. So I think that's the difference for chemistry. Engineering, there's a lot of design work and things that probably can be done remotely, but once again, capstone projects, which are so critical to the engineering discipline, those are very group oriented, right? And so we have to think creatively of how to continue that. We cannot let that, we cannot put that into individual work. That is too critical for that discipline.
An excellent point. I thank Steve for his comments at the end here. He's inviting people on the call to share some of their experiences if they would like to record them here. And I think that would be wonderful. Does anybody want to share some of their online experiences as relates to these topics? Heather, please. And then Kate.
And I would say my experience teaching not only at the end of spring, but then this summer has really taught me a lot. And in science, I think we realize failure is one of the things that we grow the most from. And I would say, so I had this summer, I taught on Zoom, and I would put the students into a breakout room. I will never do that again. It was difficult because I would come into the room, ask them questions, and it was obvious that everybody had their video off, everybody was muted. Who knows if they were working? I didn't know, and it was apparent from their lab reports that learning was okay. There were some good parts of it. Actually, and it's neat, I get to work with Emily Hardegree-Allman, and we designed the lab so that they had an indoor lab with me and then an outdoor lab with the telescopes, and they bought these Galileo scopes like the one I have behind me. That was fantastic. I would definitely recommend doing that, getting gear into their hands where they actually go out and do observation. That worked really well.
Thank you for sharing that. Kate?
Yeah, I was teaching the Modern Lab. It's a 300 level course. And the way that that course is set up is it's supposed to be quite open-ended discovery for them in a way. Like the instructions in the lab manual are pretty, like they're guides, but they kind of have to figure out what to do, which I love about that course. When we went online, what we decided to do was to make videos of basically the instructors doing the experiment. So introducing them to the equipment and things that had to be done, and then send them the canned data. And you know, all of the grade of that course is the lab write-ups. So the course basically turned into a data analysis and writing course, which are important skills, but it definitely lost that exploration part of it. And that's why I'm really interested in thinking about ways to do simulations or something where they can do a lot more messing around, poking things like that, like they'd been used to doing. But thinking about what Heather said about like, what do you think are the important things to take away from the course? Like, what do you want the students to learn? I realized that the two main things are how to write a lab report and how to converge on what data to take. So we got basically half of that from doing the online.
Do you think any of the suggestions around having students direct instructors to take data would be feasible, or do you just have too many people?
It would be very, very time consuming for the instructors. I mean, they spend, I think they're supposed to spend like 9 hours doing the labs when we normally have the course. So that would be not feasible, I would say, but we might be able to do a modified version of that.
Maybe if everybody got to do it for one lab and then the whole class analyzes the data from them or something, I don't know.
Oh yeah, something like that. Yeah, we could try to do something like that. Mm-hmm.
And then they have at least one chance at creating lab protocols. Well,
I mean, there was one really good benefit to the videos, which was that we designed them ahead of time to sort of answer a lot of the questions that we knew were coming up a lot. And when we're in the course, like there's a lot of going between groups and answering the same questions over and over again. So it was like, in a way, it was like more efficient because we basically put it all in that. We put all of those questions in there. And actually, I think the students appreciated that because they could go and look back at that for guidance. You know, maybe the first time they saw it, they didn't really understand why we were saying these things. But then after they looked at the data a little bit more, they were able to appreciate some of the things that we had said. And having that as a recorded thing is a lot easier for them rather than having to basically ask us again, like a couple weeks later. So I don't know which one's better for learning, but they seem to like the fact that they could go back and actually see, you know, what we had said word for word.
no, that makes sense. Thank you for sharing. Does anybody else want to talk a little? Yes, Martin.
I had a question for Heather about whether there had been any surveys of the teaching assistants in courses in large institutions, which is, I think, a very different experience than when you have a small college and the course instructor is the one running the lab. as opposed, they have complete autonomy, whereas the teaching assistants in a research university really don't have that sort of freedom to do whatever they want. Just wondering if you'd heard anything from them.
Yeah, unfortunately, no. It's a hard population to actually get access to from folks outside of that institution. I can just say for our own TAs, they found, our own sort of frustrating experience because they were sort of thrown in and didn't really understand like what they were doing or why they were doing it. And so we can think about better sort of TA training going forward, but we don't have a lot of data from TAs, unfortunately.
Thank you. One last call for sharing experiences. I think we've heard from almost everyone. And I want to thank everybody for participating. I learned a lot and enjoyed the discussion very much. Steve, do you want to say anything to wrap up about future events or anything like that? I will turn it over to Steve.
Yeah, hey, thanks everyone. I really appreciate your time this morning, all the participants. And I wanted to just especially thank Heather for interrupting her time away from the university in order to present today. That's awfully generous indeed. And also to Kristan Corwin for, as I mentioned at the top of the segment, for organizing, being instrumental in organizing this session. And thanks for moderating as well. Appreciate everyone's input. We'll let you know when this is posted and made available to the public.